Hi guys, good morning. So in today's daily Leetcode challenge, we have this question: height of binary tree after subtree removal queries. If you have not read the question, then please go and read because I am not going to explain the question here in detail. So in this question, we are given a binary tree and an array queries. And for each query, we have to remove the subtree with queried node and return the height of the tree. Let's start filling the output array, then you will understand. So for the first query, we have to remove the subtree with which starts with third node and then return the height. So if we remove this, then the height of the tree will be 3, right? So it will be 3. And for second query, if we have to remove the subtree which starts with the node 2, right? Then also the height of the tree will be 3. Now if we remove the subtree which starts with fourth node, then height of the tree will now be 2. And our last query is this one. So if we remove the subtree which starts with 7, then the height of our tree will be 2. So now the question is how to solve this problem. For this, I am assuming you have solved the max depth of binary tree question which is there in Leetcode. So what is depth? Depth is basically the max number of nodes we can get by traveling in any certain direction, right? So for this tree, the max depth will be 4, right? So let's take any level, right? For any level, we can calculate the height of the tree if we know the depth, max depth from that level. We can write a formula. Height is equal to level plus max depth minus 1. Let's see again. Let's say we are in level 1. Okay, so it will be 1 and max depth will be 3, so it will be 3 minus 1 is 3. As we know, the height of the tree is 3, so this formula will work for any level. Let's say we are in this level, so level is 2, max depth is also 2, so 4 minus 1 is 3, right? Now say we are removing any node, right? Let's say we are removing this one, so the height will be level, there is 1, plus max depth, there is 3, minus 1, there is 3, right? But there is an edge case. Let's say we are removing the node with max depth, then what will be the height in this case? So it's very simple and intuitive actually. If you are removing the node with max depth, then your height will be level plus second max depth minus 1, right? So if we are removing this, then our height will be level is 1 plus second max depth is 2 minus 1, there is 2, right? So yeah, if we remove this, then the height of the tree comes to be 2. So basically for this question we need to calculate a few things. One is level for each node, another is depth for each node, right? And another is max depth for each level and second max depth for each level. If we know these 4 things, right, then we can easily calculate the output. Let's take an example. Let's take the example of node 3, right? So level here is level of 3, which is 1, right? Now first we'll have to check, like, if something happened, sorry, if depth of node equal to max depth of that level, right? We'll have to check this here. If depth of node is 1, and max depth of that level is 3, right? So this condition fails. So in this case the output will be according to this formula, right? Level of 3 plus max depth of that level minus 1, that is 1 plus 3 minus 1, that is 3. So as you can see, if we remove this node, the height will be 3. Now let's take one other example, right? Let's take the example if we remove the fourth node. In case of the fourth node, level will still be 1, right? In case of the fourth node, level will still be 1, depth will be 3. So this condition is actually satisfied. So if this condition is satisfied, then output will be level of 4 plus second max depth of that level minus 1, that is level of 4 is 1, second max depth of that level is 2 minus 1, there is 2. So as you can see, if we remove the fourth node, the output comes to be 2. And if you are wondering like what is the second max depth of that level, it is 2, right? Definitely it is 2. So yeah, that's how you can solve this question. And when we'll write the code, you will understand properly. You might have missed a few things here, it's a hard question.
So let's start coding it up. First we'll have to initialize a few arrays level. So like one thing is what will be the size of the array. So as you can see here, it is given the maximum value of n is 10 to the power 5. So the maximum levels will also be the same. First let's traverse in a DFS fashion, fill these arrays, right? L is nothing but level. Let this DFS return depth. Okay, so if null, if node is null, then depth is 0. Here we'll calculate the level for this node, nothing but L, right? Guys, this is standard DFS. In case you don't know about it, please go and solve the max depth of binary tree problem. Here we need to also fill the uh, max depth and second max depth, right? So here, if depth of the current node is greater than max depth, then second max depth will be equal to max depth for that level. Max depth for that level will be equal to depth of that level, right? That's how we fill the max and second max for something. This is standard way to fill the max and second max. I hope you guys are aware of it. Finally we return, right? So this is basically the filling part of these arrays. Now let's come to the query part. So first we'll run the DFS with root and level as 0, right? Now we'll initialize the result array. Now we'll travel the queries. So first let's calculate the value of that node for which we need to run the query, right? The queries of I is the value of the node, right? Now let's calculate the level. Level is nothing but level of well. Now, as we discussed during the pseudocode, if depth of that node equals to maximum depth of that level, then output will be level, the formula which we wrote before, level plus second max depth minus 1, right? Else result is equal to level plus max depth minus 1. So that's pretty much it. It should run if there are no compile time errors. Let's see. I think it should get accepted. Yep, it got accepted, and it's faster than most of the solutions, so this is a good solution. Thank you guys for watching the video. See you again. Bye.